So lastly, let's take a look at putting this all together, and we're going to make a coordinate plane and place the point 1 root 3. So the x coordinate is 1 and the y coordinate is root 3. So that means the x coordinate here is 1 and this is root 3. I'm not drawing this to scale, and we want to find the angle theta. So just looking at the 1 root 3, that should trigger a bell. Hey, that is one of the special triangles. And 1, 2, root 3. So the missing side is 2. You could use Pythagoras again to calculate it, but if you've memorized it, then you're good to go. You can just put the 2 in there. And because it's the special triangle, you also should have memorized that this is 60 degrees. So now, what are the primary trig ratios? Well, the sine of theta is y over r, which is root 3 over 2. The cosine of theta is x over r, which is 1 over 2. And the tan of theta is y over x, which is root 3 over 1. So here are the primary trig ratios based on this information. Now, what is the exact value of theta? I've just saw that it is 60 degrees. So theta is 60 degrees, and I know that because I've memorized my triangle. So what happens if we're given the cosine ratio is -1/2? Well, -1/2, hey, isn't that one of the special ratios? Yep, it is, and it's theta is in quadrant 2, so here I'm going to draw it into quadrant 2. Here's theta, and I'm going to draw my triangle with the x-axis to identify the reference angle. So here's my reference angle, and the trig ratio cosine theta equals -1/2 tells me that the x value is -1. So the x value is -1 and the radius is 2. So I know that this is one of my special triangles, and the missing side is root 3. And it's positive root 3 because we're going up on the y scale. So I have my diagram, and I know that the angle in here then has to be, it's a 30, 60, 90 triangle, so this has to be 60 degrees. So what are the sine and cosine ratio? The sine ratio, I can just use the lengths of the sides for this. The sine ratio is y over r, which is the root 3 over 2. And the tan ratio is y over x, which is going to be root 3 over 1. And I simplify to that just to be root 3. So I didn't need to use the reference angle, I just drew that to show you that you can identify it and use it in maybe in a different way if the question was asked a little bit differently. So we're going to use these special triangles to find the y coordinate on the terminal arm of 60 degrees, and we're going to find the exact value. So when you see this exact value, it is code word for a no calculator. So we're going to draw a picture first. 60 degrees is in the first quadrant. There's 60 degrees, and we know the radius is 10. And we are going to draw our triangle with the x-axis. Here's the x coordinate value, and here's the y value for this. Now, because 60 degrees is a special triangle, and hopefully you've memorized that or in the process of memorizing it. There it is. Compare these two triangles. They're both 60-degree triangles, and compare the size of the radius. Notice that this is 5 times larger. They're similar triangles, so if the similar means they're all the same angles. So if the hypotenuse is 5 times larger, so are the other sides. So that means this has got to be 5 times 1, and the y value has got to be 5 times root 3. So what is the y-coordinate? The y-coordinate is 5 root 3 for this problem.